All right, so today we have section 3.3. This is going to be like day 1 of section 3.3. We have corresponding angles converse, alternate angles, alternate interior angles converse, alternate exterior angles converse, consecutive interior angles converse. So remember, converse is when we take that if-then statement and we switch around the stuff. Sometimes it's true, sometimes it's not. These are true. If we first have two lines cut by a transversal, and we find out that the corresponding angles are congruent, then that makes the lines parallel. Let's quickly draw a picture of that. We didn't draw pictures yesterday, and I felt like it would have helped some of you to have those pictures. So let's draw, if we have two lines cut by a transversal, and if we find corresponding angle congruent, so let's mark some of the corresponding angles. If we find out that these two corresponding angles are congruent, then that's going to tell us that these lines are parallel. So it's backwards. Yesterday we were saying they are parallel, which makes the angles congruent. Today we're saying if they're congruent, then the lines are parallel. So it's the exact same stuff, just backwards, converse. So alternate interior angles converse. If we have two lines cut by a transversal, there I have two lines cut by a transversal, and we have alternate interior angles that are congruent. So here's an alternate interior angle with this one. We have two alternate interior angles that are congruent. What's that going to tell me? That the lines are parallel. Alternate exterior angles converse. If I've got two lines, and those were really bad lines, sorry. We have two lines cut by a transversal. And if we have alternate exterior angles congruent, we have alternate exterior angles congruent, that tells me what? That tells me the lines are parallel. If we have two lines cut by a transversal, and when we have that, we have two consecutive interior angles that are supplementary. So, I don't know, this one is 95, and this one is 85. If we have two supplementary consecutive interior angles that are supplementary, that's going to tell me what? Besides Rikaya, that's going to tell me what? A little bit louder. Well, yeah, if they're supplementary, they're going to equal 180, but what does that tell me? What's this converse telling me? Matthew, what's the converse telling me? That what's parallel?
Two lines.
The two lines are parallel, thank you. All right, find the value of x that makes line M parallel to line N. That's what that says right here. Find the value of x that makes line M parallel to line N. So what kind of angles are these? What kind of angles are these? 3x plus 5 and 65 degrees. Let's see, they are in the top. Here's the two lines. Here's the transversal. They are both in that top right corner. So they'll be corresponding angles. So in order to make these parallel, what do corresponding angles need to be? Emily, in order to make these parallel, make these lines parallel, what do we need to show that the corresponding angles are? Congruent. And you show that they are congruent. So if these are congruent, how do I set up an equation, Donovan? What's congruent mean in an equation? Equal. So I'm going to set them equal to each other. 3x plus 5 equals 65. I'm going to subtract 5 from both sides. What property is that, by the way? Subtraction, property of equality. We're going to get 3x equals 60. Divide by 3. What property is that? Division, property of equality. X equals 20. And we're done. So we used which converse theorem? Which converse theorem did we use? What's it called? Austin, what's it called?
Corresponding angles converse.
Perfect. So, corresponding angles converse. All right, how about question B? So I'm looking at 72 degrees, and I'm looking at 4 parentheses x plus 5 degrees. They're both exterior. And where are they compared to the transversal? Are they alternate exterior? They're not alternate exterior. They're like same side exterior. Do we have a same side exterior theorem? Is that a thing? No, that is not a thing. So we should find something else. So if I'm going to number, I'll number these real fast so you can talk to me about which angle you're thinking. 1, 2, 3, 4, 5, 6, 7. What angle should we find so that we could set up an equation using one of our theorems? What angle should we find? Alex, what do you think? Okay. Excellent. How many people were thinking angle 7 by alternate exterior angles? Not everybody? So what was that, somebody else thinking? Okay, what were you thinking? Angle 1. Well, what theorem would allow you to find angle 1 from the 72? Linear pair. Yep, linear pair postulate. So you could find angle 1. They're supplementary. And then from there, 1 and this one would be alternate exterior. John, what were you thinking?
Angle 3.
Angle 3. Because why? Linear power postulate. And then what would you do? No, not that. I mean, like, so once you find angle 3, then you would set it equal to this, or set it?
Oh, I would do 4x, or 4 versus x plus 5, or 72.
Where are you getting the 72 from? Did you do more than you said? I think you did more than you said. So if you did angle 3, that's not 72, right? Did you find angle 3? So you were saying it was corresponding to 3, and then you just used like linear pair kind of, but not actually using the pair. Okay. All right, well, I'm going to go off of Alex because I called on him first, but like there's way different ways of solving this, and when you guys look at my answer key, we might have done it a different way, so you can't like totally go by the one way I did it because I'm not going to do it the 18 different ways. That's ridiculous. All right, so if you have questions when you do check your answers, definitely ask me about it, but we could both do it a correct way, different ways. So Alex said that angle, oh, now I forgot what you guys said, Alex. Angle 7?
Yeah.
Oh, you said alternate exterior for those. So angle 7. Oops, I forgot to write the angle 7. Measure of angle 7 equals 72 degrees by alternate exterior. And then from there, angle 7 plus 4 parentheses x plus 5 degrees equals 180. Because those are linear pair postulate. They make a linear pair, so they equal 180. So when I have 72 plus 4x plus 20, what property did I just use? Cameron? The distributive property? And then 4x plus 92 equals 180. What did I just do there? How many? Not quite. I did add, but I didn't add it to both sides. Simplify. Yeah. Collect like terms, simplify, something like that. I just write simplify. Now we're going to subtract 92 from both sides. 4x equals, what is that? 88? Is it 88? Help me out. Is it 88? Yeah, it's 88. Okay. What property is that? Subtraction. Prop of equality. Divide by 4. Division. Prop of equality. Done. That's all we're doing today. Worksheet? All right, worksheet time. That's your assignment. I also have, right before I stop it, I also have, after you're done with your worksheet, we're going to be learning some more constructions coming up, like block day, we're going to learn some more. So I have a little review packet where you could review how to do the 4 constructions that we have learned. It has the step-by-steps in it with pictures and then just 2 examples for each of these. So you guys have a 30 minutes to work on this and or the worksheet that I'll be handing out to you. Okay?